All right, so today we're gonna solve a question on Leetcode. It's an easy question, power of 4. Pretty simple premise, return true if the number or the integer that's given to us, if it's a power of 4, we return true, false otherwise. So yeah, so I will give you a little bit of intuition about what the problem is. So the way I approached it was, using bit manipulation. So let's write some power of 4. So we have 1, 4, 16, and 64. So these are some of your powers of 4. So if we convert them to binaries, we will actually get something like this. So these are your binary numbers when you convert powers of 4 to binary. And I mean, you can see a sort of a pattern over here. There are two things that you should notice when you see something like this, since one thing that you will notice is that there is only one set bit in all these numbers, right? And that makes sense because all power of fours are actually 2 to the power something. So all the powers of twos have only one set bit. So we should see that in power of ones as well. I mean power of fours as well. Secondly, also we see that there is a specific position for one. So let's see. Over here, it is you can say it is on the index 2. Over here, it is in index 4, right? And then over here, it's index 6. So this one cannot be just anywhere, this one set bit. It has to be on the position uh, that is uh, that is an even position, and that makes sense because basically you can have something like let's say 2 to the power 2a, so some raised to the power, let's say it's being raised to the power something even. It's actually that is the same thing as writing as 2 to the power 2 uh, raised to the power a. So we just take the 2 inside. It's the same thing. And this is actually nothing but 4 to the power a. So if it's an even number, if there's an even number here, you can always convert that to the power of 4. So that's why it's important that this one set bit is at the even place. So yeah, so we can, I guess, start coding this problem now. So firstly, we'll have to do a check. If this number is less than 0 or equal to 0, then we know we will return false because you can't have something raised to the power of 4 cannot be negative. That's not how it works. Then let's start. Then we have to know the number of set bits, right? So let's get let's make a variable set bits, and we can also have something like a I, which would tell us, since we have to know the index of that one, we will keep this I as well over there. So this will tell us this is basically index of that set bit. So again, we're gonna go while n is more than 0, right? So so we're gonna go bit by bit. So let's say if it's a 32-bit integer, it will go 32 times. So if and so if this is a set bit, if the last bit, the rightmost bit is currently set, then we will firstly increase that bit. So this is like a bit count, right? So we'll increase that by 1. And if set bits is more than 1, or the index currently is also, it's a odd index basically, right? So this I mod 2 is actually just equal to 1, but you can just write it like this. We will return false immediately because these are our two conditions that I explained earlier. Then we can just increase this by 1, and we can just go n is equal to n. We'll just right shift it by 1. Also, the same thing as doing this also. So whichever you prefer. If all this checks out, which is going to return true. So let's do that. And let's try to run this code, see if it compiles. Okay, so the cases are passing. So these dummy cases are passing. Let's submit. Great. So it's getting expected. It is getting accepted by Leetcode. Yeah, thank you.